you can watch it later. And then I'll share my desktop. Okay, so yesterday we looked at how what we looked at yesterday was I was trying to illustrate the major themes in solving an engineering problem, engineering analysis. So what it always is, you have nobody will tell you to if you're an engineer, I ask you to design something. Nobody, it's not going to be like a textbook problem, right? That they simply say, okay, this is what is happening, and you substitute in this equation and get a solution. That is not going to be the case. In real world, you look at a system or a process, and if you want to understand how it works, or how if you want to make some decisions about it, like in this case, I told you the decisions are what should be the rope, how thick the rope should be, how to keep him safe, how to pull him up after he's done, and all those things. So you should ask yourself, what are the key physics involved here? Using those physics, you come up with a equation, and then you have to solve that equation. So yesterday, I think I repeated it several times. I told you that the physics is going to be, typically speaking, the physics mostly is going to be conservation of mass, conservation of momentum, conservation of angular momentum, conservation of energy, that sort of things. And also there are some supporting laws, like you have mentioned, laws of friction, laws of, you know, I don't know, I think you said Hooke's law, Lenz's law, Coulomb's law, and all those things, Ohm's law. Yeah, sure. Those are all from physics. You should know where to use them, how to use them, how they are applicable. Whenever you see an opportunity, whenever you see, a problem, you should know which laws are applicable here, which laws you should bring in here and use them. And here in this case, I told you this is a simple case of mechanics. You do the conservation of linear momentum, which case, the rate of change of velocity of this person is going to be acceleration due to gravity minus, the deceleration caused by the wind drag. Okay, so this is the equation, and this equation turned out to be a differential equation. And yesterday's class, I showed you how, if you know a little bit mathematics, if you are a little bit well versed, if you're very comfortable with analytical methods, how, because it's not a straightforward thing. If you have to integrate it, it's not a straightforward thing, right? We have to do some manipulations. We had done a variable transformation and replace the variables, and then realize that this is, it's not like it's not like I knew it, right? In the textbook, the solution was given, and I knew how to solve it. But if a problem comes in real life and there's a complicated differential equation, you may or may not be able to solve it analytically. So you have to think in terms of numerical solution. So this is the analytical solution, and I just had another class. I was writing in red pen. This is the numerical solution, but we'll go back. I'll first of all show you a few things of how to solve this in Python. If you remember, I told you, even if you want to choose analytical method, see, now this is the analytical method. For any time, given time t, you can substitute the time value, you will get the velocity value for that. That you could do. But even that, I strongly suggest that you use a computer program. And I'll tell you why now. Okay. So now I think what I will do is we'll move on to I'll show you how to use what is it called, Python now. Okay, so I'll close this one. Okay, I'll change the name this one because I was just doing this for section C. Okay, section C. And let me call that one first one. Okay, I'll close this as well. I don't know why it's not allowing me to do that. I'll close this one, that's no problem. Okay. Okay. So, in this class, we'll be using Python. Okay. You guys all know Python, right? Uh, and you should have some sort of way to, you should have some provision for being able to run Python. And now I'll suggest two alternatives. One is if you have a laptop, okay, then you install this Anaconda Python. In in Google, you say Anaconda Python, okay, and this website, it'll say individual edition Anaconda. You go there, and it says your data science toolkit, says it is actually mostly used in data science. And here individual, you can say download, and there are options. See, the installation file is different for Windows, Mac OS, and Linux. Most of you will have Windows, and unless it's a very old computer, it is a 64-bit Windows you'll have. So for most of you, this will work. And if some of you has a Mac, Apple laptop or a Linux laptop, you could do those things. If you have, when I say a laptop, it could be desktop also, but a personal computer. If you have a personal computer, whether it's a desktop or a laptop, most likely it is a Windows and 64-bit Windows. But it is possible that some of you may have an old one, which could be a 32-bit uh, computer, but generally this one. So what happens is if you click it, it will start downloading a file. See, that is a file. You can download it at any location, and you have to run that. You'll have to run that file. You'll have Anaconda on your computer, and I'll show you how that will look like. Anaconda. For some reason, they give all kind of scary animal names for this. Anaconda, Python. Okay, this is my app, Anaconda, and I think there should be. No, I didn't make a desktop shortcut, so that's how I'm doing actually. Anaconda, Anaconda Navigator. So that is Anaconda Navigator. I can simply say open. It'll take some time on my computer because my computer has become very slow, even though it's a very good computer. So that is one option. And what it provides you with is an integrated development environment, IDE. How did you do? How did you do Anaconda? No, how did you do Python when you were in first year? What were you using to run Python codes when you learned? Were you using Spider Node?
Ideally, sir.
What is that?
Ideally, sir.
Ideally. Ah, okay. Ideally. Yeah, that's a simpler. Ah, okay. Yeah, you could do that. If you have a good computer, I'll suggest using Anaconda. But ideally is also good. Ideally, if you want to install, that is also good. I think. Let me see. It's not extremely important what do you use, but I think ideally is also good. I have seen people use it. Python, I T. So this is what you have probably used, right? Python.org, and this directly comes from Python itself. Okay, I think this you download. I think it's simply you don't get the ideally. No, I'm trying to figure out how I have done it before. Download the latest version for Windows. This is not with IDE. This is documentation. Okay. Okay, I think maybe I was wrong. I think this. Hmm. Maybe I'm wrong. I think maybe this one comes with ideally directly. Okay. Anyway, so this Anaconda, it will look like this. It has a lot of other. It is a launch it's a navigator from which you can launch different tools. What I think we'll use is Spider. Spider is the IDE for Python. I think I have ideally also, if I'm not mistaken. IDLE. Yeah, this is ideal Python. So I think if you're already accustomed to it, maybe that's a good place to start. And also, this is less heavy compared to the Anaconda, meaning it's a simpler program to run. And you see, I have 64-bit computer. Anyway, I think it's taking time to open Spider. Now, here's the thing. If you have a computer at home, be it a laptop or a desktop, then you can do this. You can install Python in your computer. But if you don't, uh, okay. So here's the thing. I think this is ideal. This is what you're doing, right? Ideally. Yeah. This will work. You can run your code here and it will, you know, okay. So this you could do. Ideally is okay. I think could you go to the Python website and you can get it. I'll not use it now. Is it quit then? Exit in brackets. Okay, why not? Okay, so this is Spider. Like I said, it's a little bit heavier, but it is a better environment also for running. Um, then I was saying, see, if you have a laptop, you could do all those things. What if you don't have a laptop? You should still be able to run the programs, right? So what I suggest to you is, in that case, you could use online Google Colab. What does that mean? No, you go to google.com. Okay, here you say Colab, Colab, Colab. Okay, Colab. The first link that comes out is Google Colab, and I'll tell you what this Google Colab is. See, going forward, everyone is talking about cloud computing. Do you know what cloud computing means? Okay, see, people now they don't they want to be the reason they call it a cloud is no, cloud is always above your head. You could be in Madanapalli or you could be Bangalore, Hyderabad. You can always see the clouds in the sky. So that's how they want to do with the computers also. Your work will be stored in a central location somewhere. Wherever you go, without having to carry the computer data and everything, wherever you go, if you are able to carry, okay, so this is how the spider looks like. This is what you get from uh, Anaconda. And it looks little better, but again, this is a bit heavy program. So same thing like ideally. See, ideally also you have an editor window. Here's where you can write the program, and this is console where you'll see the output of the program, or you can directly give commands here also. Okay, and slowly you can learn the meaning of all these buttons and menus and how to customize it and all those things you can learn. Okay, so these are the options. If you have a laptop, you install the IDLE or you install Anaconda. If you don't have it, then we'll use the Google's cloud computing. See, all the big, see, so now this is a big business in computers. If you want a powerful computer, let's say for one calculation, and you don't expect to use that kind of powerful calculator all the time, but only at some times, then there is no point in buying a very powerful computer, right? It's better to rent a computer. So what Google and other companies like this are letting you do is they will provide the computers for you, and it's kind of, they say it's a cloud. They'll put it on a cloud, and you can, using your simple computer, simple laptop, or even a phone or a tab, you can connect to that powerful computer and perform all your tasks, all your computations, all your analysis on that server or a remote computer from any electronic device, any smart device. This is called, this is one aspect of cloud computing. There are other aspects also. What we are talking about right now is running, like checking out computational power when you need it. For example, if you use their computers for 1 hour, you only pay them for 1 hour. So that way you can get your job done for less, not having to buy a computer and then maintenance of the computer, upgrading of the computers. Everything is taken care of by somebody else. They're just letting you use the computer. So all the major companies these days, Amazon, Google, IBM, they provide this kind of service to companies, and companies are now using this kind of services more and more because they can scale up and scale down easily. Okay, let's say a new employer is joining. In old days we have to buy a new computer for him. Now they simply give a simple laptop and they say, okay, ask Google to provide another back-end server for him. Or if they're letting go of people, then they can stop paying rent for the 100 computers. If they're, let's say, getting rid of 100 people, meaning they're firing 100 people, it is easy to simply say that they'll just tell the Google that, okay, we don't need these computers anymore. The additional computers we don't need, we'll not pay for it. So scaling up and scaling down is easy. Now, I don't want to talk too much about it. All you have to understand is now there are ways where you can simply run your program on a remote computer by paying money to the companies, depending on, and how much you pay will depend upon what kind of computer you are renting from them. And when I say renting, it doesn't mean they'll give the computer to you. It will be available on the internet. You just connect to that computer and use it. And that is what we'll do now using Colab. Even though Colab makes you pay for this service, the most basic version of it is free. Okay, that is what we'll use today. Google Colab. If I click on it, I'm already logged in, so it will show me all my original, or what are the notebooks I'm working on. If you're not logged in, you'll have to log in using your Google ID. Okay, log in using Google ID, and then you can say a new notebook. Okay. When I say a new notebook, this is when I'll be connected to a Google computer. Okay, this is my notebook and I'll call it section B. Section B and the first program. Okay, that, and now I'll say connect. When I say connect, then it gets connected to the, no, this command will give me a connection to the one computer in the backend that is provided by the Google. So this is so nice, right? Because all I need is a browser, and you have a browser on your cell phone also. So go to your cell phone, use a browser, and we don't need to install anything in your computer, Python and all, because this is running. See, they have Google has provided us with RAM and disk, and if I roll this onto it, say it says connected to Python 3 Google Compute Engine backend, and I have a RAM. They're providing me with a RAM of 12.72 GB. I can do kind of very serious computation with that, and they're giving me 100. So it is like now I have a computer with 12 GB RAM and 100 GB hard disk available with the Google. I could use that and I can do computations. So this way you'll be able to do programming Python from your phone itself, and you can do some serious computations also, very complicated complication, because the program is not running in your cell phone, it is actually running in Google computer in the backend. I want to pause here. I'll give you an opportunity to ask questions. Do you have any questions about what I covered so far regarding Python? Anything? So you guys there still? Are you with me? Okay, so good to
Yes,
see
sir.
you all. Good to see all of you. See, what I'm saying is, as we go on, you should be able to run Python programs. You should to find, you should find a way how you can run Python. As I was telling you, there are two options. If you have a laptop, you have both options. With a laptop, either you can install Python using idle or Anaconda, or alternatively, you can run in the Colab. But if you don't have a laptop, then the Colab is the only way, because using this you can connect, you can run Python in your phone also. But I'm telling you what Colab does is, it will, Google is giving you, letting you use a very powerful computer. Whenever whatever you run here, this your commands are sent to the Google backend engine, compute engine, and it performs the calculations. You're not running anything on the computer, so you don't have to install anything also. You don't have Python on your computer also, it will run. Is it understood? Anyway, I think you all try that and we'll clear doubts as we go on. But I strongly suggest that you all try to do this your phone. No, you all try to do this using your phones. Okay. So now going forward, this is a notebook. In notebooks, whatever we enter in a notebook, it has to be either code or text, and each piece of that is called a cell. See, this is a notebook and I have two buttons here, plus code plus text. What this means is adding or inserting a code cell, or adding or inserting a text cell. So right now this default one, there is a text cell, code cell here, and there are other things, we'll learn it slowly. If I say text, okay, this is a text cell, meaning I can write some text here. I'll write a text, I'll say, okay, I'll say hash. No, this is the formatted text, hash. I'll say, Python session 1, and I'll say 2 hashes. You'll slowly understand what this means. See, because I said hash, it knows that I want it to be the heading. I said 2 hashes, and I'll say section. This will be a second level heading, section B. Okay, and this I'll put a date here. Date is 29 August 2020. Okay, and I'll give some description. This notebook contains the program for calculation of for solving the bungee jumper problem. We'll say bungee jumper problem. See, that is a text cell, and I'll move it to the top. See, so this is the first cell, text cell. Then there is a code cell. Here I'll write the code for solving the problem. Okay, so we'll go back to that problem again. Maybe you forgot, maybe you lost track of the things here. Here's the thing. So this is the equation. So given the time, we want to find the velocity, and this is how I'll do that. So first of all, we have to store all the variables. G equals 9.81. Okay, this is a basic type of command in Python, which is called an assignment command. What this command does is, I'm telling, make a variable called G and assign the value 9.81 to that G. Another way of saying that is, make a variable called G and store the value of 9.81 in that variable. Okay, and then this is not needed, but I'll tell you why I did that later. And G and mass of the body, I think, let's say it's a 70 kilogram man, and then CD. Okay, I think you may be confused why I'm doing all this. I'll tell you. Uh, Okay, you see, the model can be used to generate a graph. Example, velocity of a 68.1 kilogram jumper. So mass is 68 and drag coefficient is 0.25. G, you know. So in this equation, we have those parameters, G, M, drag coefficient, and time. So we have to give these, and then we can evaluate this expression. The expression is Gm by CD square root hyperbolic tangent of GCD or M square root. Okay, G M over CD, G CD over M. So that's what I'll do there. Oh, I should not have, that was not necessary. Okay, anyway. So I'll go back to this. So see, we have to know the values of this. So CD, I think the textbook takes value of 0.25. We'll also use that one. Time, time is at whatever time you want the number, you can find. Let's say, let's find out what happens after 3 seconds. Okay, now velocity, what is the expression I said? G times M divided by CD, and we have to take square root of this. One way to do the square root is, we'll say raised to the power half. Raised to the power half is same as square root, right? So that exponent raised to power in Python, if you okay, are you able to see, by the way, are you able to see what I'm typing here? Is it legible to you? I think some of you are watching from
Yes, sir. Yes, sir.
even on the
Yes,
cell
sir.
phones, is it visible?
Yes, sir. It's visible.
Okay, that's good. So see these two asterisks here, multiplication. This is a different operator, that is a power operator. For example, if I say 3 power 2. What do you think we'll get? That is 3 square, 3 raised to 2. That's how you'll write 3 square in Python. If you run it, you'll get 9. Okay. Now I'll tell you, whenever you have a code cell, you can run each cell separately. Each code cell, if you scroll there, you'll get this button. If you press this button, that cell will run. Okay. And whatever output for that cell is, gets printed immediately below the cell. That is 3 square. 3 cubed is 27, right? Okay, that's what this is. But we want to raise it to 0.5 square root. Okay. So this is the key. You have to know, given a mathematical expression, you have to know how to convert that into a computer expression in Python. Times, this will not work, but I'll show you tan hyperbolic. And then inside the tan hyperbolic, we have, I think, G times CD divided by M. And then this is square root again. So power 0.5. Okay. So times T. Okay. So this is the expression. And if I run this, it will not run, I know, because this tan h function is not available directly in the tan c. It's CD, doesn't like CD. Okay. Okay, we'll fix that. I think I used capital CD there. This is case sensitive. In Python, I think you will know variable names are case sensitive. So now it will give an option. It says that it doesn't know what tan h is. See, in your equation, you'll have to evaluate this expression. You have to evaluate tan hyperbolic for this quantity. But Python says it doesn't know. It doesn't know how to do tan hyperbolic. It's okay. The base thing does not have it. What you have to do is you have to import. There are functions, math functions, which are not directly available in Python, but we can get them by importing a library. I'll say import math. So math library has a tan h function. Then you should be able to do it. So I'll run this. Now that is imported. Now, because it is in the math library, I have to clearly tell Python that I have to give the library name also. I'll say math dot tan h. No, you look at that. So I am asking it the function name. It's in the math library. So I have to say math dot tan h. If I run this, this will run. And if you want to print it, you'll simply say V. It will print it. See, after 3 seconds, according to the calculation, velocity is 26.68. What about 4 seconds? It is 33. What about 5 seconds? 38. See, isn't it nice? You can change it and immediately you'll know our answer it is. Instead of 70 kilograms, if the weight becomes 65, little bit lighter person. See, 70 kilograms man, after 5 seconds, you're saying weight velocity is going to be 38. What if the weight is 65? His velocity is going to be 37. What if he's a very heavy man? What if he's a 100-kilo man? He's going to get a velocity of 40 meters per second. And what happens after 15 seconds? 61 kilometers per second he'll be traveling at. Okay, what if velocity, what if it is a very light person, 60 kilograms, a girl maybe, 48. See, isn't it nice? No, the reason I'm saying that you should do a program is then changing things is very easy. You can easily change the input variables and easy to run the program. And the formatting also, print, you can change it. No, I'll say, I'll change it. I'll say print the velocity of. See, I think since you have seen Python before, I'll not bore you with too many things. Of a, will print weight m kilogram person or kilogram, let me say bungee jumper. Bungee jumper after, now I'll print time. Now I'm guessing you understand this, right? I think you have done this in first year. In t seconds is, and then comma b. So what I'm doing is, earlier it's only printing 48 numbers, right? Now I'm printing a formatted print. I'm telling the computer to print it like this. It print a string called velocity of a, and then print the variable m, whatever it is, kilogram bungee jumper after, then variable t, that many seconds is, then variable v velocity. So if you run this, it will print a formatted output. See, we're getting a nice formatted output. It says the velocity of a 60 kilogram bungee jumper after 15 seconds is that much. And if it is going to be a 100 kilogram bungee jumper, 100 kilogram bungee jumper after 15 seconds is, see, he's traveling at much faster velocity because he's heavy man. Okay. Any questions so far? No questions?
Hello, sir. When will you use import math, sir?
What is that?
Sir, when will you use import math, sir?
When will I give you what?
Sir, when will we use import math, sir?
When will we use import math? Okay. Okay. See, whenever we need functions in the math, okay, this is a good question. For example, okay, for each of these libraries, if you want information, you can go and do the Google on it. Generally, not just math, all libraries, we use them when you need them. Here I used it because I need tan hyperbolic. Okay, to evaluate this expression, we need tan hyperbolic, and the tan hyperbolic, we can only, that function is available in math. So that's why I imported math. If I did not need this one, then we don't need math function also. Similarly, there are specific functionalities. See, Python has lot of ability, lot of functionalities, but not all of them. It doesn't make sense to have all the functionalities open all the time, because that will, uh, you know, that will overwhelm your computer. If you load, if everything is compiled and ready to go, that will make a very heavy program. Instead, for example, Python is used in data science, Python is used in scientific computing, Python is used in signal processing, Python is used somewhere else, somewhere else, somewhere else. So each different groups of users, they'll need different set of functionalities. You see what I mean, right? If the Python is being used by somebody who's a statistician, he needs different functions to do his job. When Python is being used by a scientific programmer, he will need different functions. When Python is used by somebody who is doing signal processing or somebody who is doing machine learning, they'll need different sets of functions. They will want to use different sets of functions. So the basic one will have very limited functions. On top of that, if you want to use anything specific, see, we are using for what we are doing, it will be called as scientific computing. So we need things like math and NumPy and matplotlib. So that way, depending upon your need, you have to know which library has the functions that will be useful for you. and you'll have to use math. You'll have to import that library, whichever has the functions that you think you need to do the task that you have at your hand. Here in this case, tan hyperbolic is not available in the basic standard version of Python. You have to extend its capabilities by importing math library. Now that library has the tanh function, which you are able to call and use here. Does it answer your question? Okay. Well, this is only the first day. You'll slowly catch on and you'll understand that. I'm not worried about that. Any other questions? Okay. So now, instead of doing it, instead of doing it only at one time, let's say I wanted to calculate it from 1 seconds to 10 seconds. Then I think there are many ways to do this, but I'll tell you the simple, straightforward way. I'll add here. I'll add comments to these things. The following cell imports the math library which has the required tanh function. That is that. Now I'll say the following code cell contains the program to calculate the velocity any given time for a bungee jumper of given mass. Okay, that's what this code does. See, these are the text cells. I'm adding the text cell so it explains you what is being done by the program. Now I'll add another text cell. I'll say in the following code cells, we will try to calculate the velocity of the bungee jumper at different times. Okay, now I'll show you a few things. Okay, I'll import another library called NumPy. I'll call it as NP. Okay, so this import and that import are same, but here I'm saying as NP. What this as NP does is it will rename for the sake of this program, it is renaming the NumPy library as NP. The reason I'm doing it is because later on, see, whenever we call the functions in the library, we have to call the function along with the name of the library, math.tanh. Similarly, in NumPy, later on, if you want to call any functions in NumPy, you'll have to call it as numpy dot something. If you are a little lazy or if you don't want to type the whole thing again, and there will be too many letters or alphabet in your code, then I'm shortening the name. Say instead of using the full name, you're telling the compiler that instead of using the full name, you'll use simply NP. Okay, that is that. And I'll tell you why I have downloaded it in a second. But let's say instead of one number t, you want to get it for 4 numbers. T equals 0, 0.2, 0.3, 0.3, no, okay, zero point 0.4 actually, 0.4, 0.6 and 0.8 and 1. Okay. Now T is an array. T is an array. T has this. So what if you want to, you have an array, you want to calculate velocity for each of these times for 0, 0, 0.2, 0.4, 0.6, 0.8 and 1. And the first thing is you want to create an array like this. And there is a, see, the thing with the array is this is an array of equally spaced elements. The space, the interval size is same. See, you add zero point 0.2 to the previous element, you get the next element 0, 0, 0.2, 0.4, 0.6, 0.8, 0.1. If you create an array like this, later on you can use that for other calculations. If you want to create an array like this, one method is just doing it like this, and it's not very convenient because I want to go from 0 to 12 seconds. But why did I say 12 seconds? No, I'll tell you. Eventually, I want to plot like this. See, they have a plot like this: time in the x-axis, velocity in the y-axis. They're plotting how the velocity is changing with time. So what I'm trying to do is I'm trying to estimate velocity at different times, and then I'll have a table. I'll have a table where you know I'll have the time versus velocity. Okay, let me do it in a code cell. Okay, time, velocity. So I want something like this. At 0 time, velocity is 0. At zero point 0.1 times, what is the velocity? At zero point 0.2 times, what is the velocity? So on and so forth. Okay, there are nice little things you could do. Okay, I think, see, I just thought of this. See, the text cells, you can make table in the text cell also. In this text cells, if you do this, it will automatically create a table. Hmm. Okay, I think I'm missing something here. I'll do that later. Okay, so ultimately you want something like this. Okay, anyway, uh, see, you want at different times what is the velocity. If you have something like that, then you can plot it. So first thing is to create a time array like that from 0 to, I think I'm saying 12 seconds because here there is 12 seconds. So 0 to 12 seconds they have made a plot. That's what I'm trying to do also. You could do this until 12. You can continue going on. Alternatively, there is a function in NumPy library. See, NumPy library, we have downloaded it with the name np, np.linspace. Okay, what this function does is it will create an array like this, an equal spaced array. if you want to generate this array, see, I have done all those things, right, to generate the array. That if you want to generate something like that, what you have to give is what is the starting number 0, what is the ending number 1. So to create something like this, you say 0, comma, you have to give first number, last number, and give it how many points you want. 1, 2, 3, 4, 5, 6. So if I do this 0, 6, this directly, okay, did I not run that NP thing? Okay, I have to run this. Okay, so it is imported as NP. Now I'll run this np.linspace. See, what it does is it does exactly same as that. See 0, 0.2, 0.4, 0.6, 0.8, 0.1, but you did it using a function. I said create an array starting with 0, ending at 6, and it should have, I'm sorry, starting at 0, ending at 1, and it should have 6 equally spaced points. That's what linspace means, linear spacing. Okay, and it created this array, and I'm using this because for this small one it doesn't matter. You could have actually printed the made the array also, but if you wanted to do this till 12, so what I want is it till 12 and 121. This will give you the array I wanted. See, instead of me giving each of these separately 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, this function has automatically created that array for us. See, I told you eventually we want time array, time as 0, 0.1, 0.2, because we'll plot it, right? That was automatically created using this linspace function. So this is what we'll use, and I'll say insert. I'll insert a new code cell here, and we'll use the same program as before, same program. But here, instead of using one value of time, we'll use an array. Now what I'll change here is, instead of t being a single number, oh, it's time up. Okay, so what is the next class for you? What is the next class for you guys?
Sir, DME, sir.
Who is the teacher?
Anshuman Das, sir.
Okay, okay.